Good afternoon, Doctor. Today my group is going to present about Chemical Engineering Thermodynamics project on flash separator designed for ethane and propane mixture. We are from Section 1, Group 6, and these are our group members, Chloe Bong, Noor Adila Shamimi, Tanush, and Ong Yong Chen. My name is Chloe Bong, and now we are moving to the introduction part. So for the introduction part, we are going to talk about flash distillation which we use in this project. It is often used in chemical engineering and process industries, particularly in the fields of petroleum, natural gas processing, and refinery operations. Flash distillation is used to separate mixtures, liquids such as propane and ethane for our group based on their different boiling points. So the basic principles that involved in this flash distillation is the flash vaporization, which involves sudden vaporization of hot liquid mixture to create a vapor phase and liquid phase by passing it from a high pressure area to a low pressure area at a given temperature. So we are going to use flash calculation to calculate our project. Flash calculation is a set of thermodynamic computations used to predict how a mixture will split into vapor and liquid phases under given temperature and pressure conditions. So it is important to ensure correct sizing and functionality of separators and reactors, and it can predict self-separation to enhance efficiency and minimize waste. It can also avoid issues like unexpected phase changes that can lead to operational hazards. Moreover, it can optimize the process conditions for energy savings. So for the equation, it is shown as in the slides, and the equilibrium relationship is captured by the Ki values, which is the equilibrium constants. So the objectives of our project is to separate a multi-component liquid mixtures, that is ethane and propane, into its vapor and liquid phases based on the differences in the volatility of its component.
Hello, my name is Noor Adila Shamimi, and I will cover the intro part for our calculation. In this part, we will perform a series of flash calculation to determine how the mixture ethane propane will separate into vapor and liquid phase at a specific operating conditions. Before we begin the step-by-step calculation, we would like to highlight the main references used throughout this project. These are the two books that we have used to obtain the thermodynamic data and also flash calculation methods based on these two books to complete the project. For our project, we are working on the separation of a binary mixture of ethane and propane using flash distillations. This slide represents the basic physicals and also critical properties of each component that are taken from Chemical Engineering Thermodynamics 8 editions. These values are very important because they define how each components behave under high pressure and also temperature, which directly affects how we model the vapor-liquid equilibrium. All of this data will be used in our later thermodynamic equations. Now, moving on to the second part, this slide shows the vapor pressure equation, constants for both ethane and also propane that are taken from chemical properties handbooks. We will use these constants in the equation below to calculate saturation pressures at any given temperature. This is an essential step in our flash calculation because once we know the vapor pressure of each component, we can move on to calculate the K values, which tell us how the components distribute between the vapor and also liquid phases. So, this will help when we begin the actual flash calculation to determine the amount of vapor and liquid and also their compositions.
My name is Ong Yong Chen, and I'll talk about the flash calculations. This is the diagram for flash for our calculation. From here, we assume that the overall compositions for input to be equimolar. Assume that the process is ideal state and steady state. Now, we are required to find the total output compositions L, V, X, and Y. Knowing the separation occurred between boiling temperatures of two components, we can take an assumption for a temperature that is between the T ends of ethane and propane. Now, we will assume that the temperature is 200 Kelvin. Moving on, we will calculate the vapor pressure for the species. Using formula from Chemical Properties Handbook and the constant A, B, C, D, and E, the vapor pressure or saturation pressure for ethane at 200 Kelvin is 217 kilopascals. Using the same formula, the saturation pressure for propane at 200 Kelvin is 20 kilopascals. Using saturation pressure for both species, the bubble point and the dew point pressures are calculated where we assume Z is equal to X for P bulb and Z is equal to Y for P dew. The bubble point will be at 118 kilopascals and the dew point will be at 36 kilopascals. Knowing that the operation pressure is between dew point pressure and bubble point pressure, we take an operation pressure value of 101.325 kilopascal, which is at 1 atmosphere. Since this is a binary system, we can calculate the X composition straight using Raoult's law. Here, we are showing the arrangement of formula to find X using operating pressure and saturation pressure. Using previously arranged formula, we found out that the output liquid compositions of ethane to X1 to be 0.42 and propane X2 to be 0.58. Continuing on, we will calculate the K values for K1 and K2 using saturation pressure of ethane and propane and the operating pressures, where K1 value is 2.14, which is more than 1, and K2 value is 0.19, which is less than 1, which shows that separation does occur. Using K values, we can calculate the Y compositions of both species for the output, where Y for ethane is 0.88 and Y for propane is 0.12, which shows that vapor compositions is mostly ethane. Combining K values and Z values, we can finally find the overall vapor compositions V and the overall liquid compositions L for the output. V is 0.19 and L is 0.81 at 200 Kelvin and 1 atmosphere, which states that the flash is mostly liquid.
Okay, I'm Tanush. I'm gonna explain about the PXY diagram and the TXY diagram. Okay, the figure shows the PXY diagram for the ethane and propane at constant temperature of 200 Kelvin. PX1 curve, which is the blue curve, is also known as the locus of the bubble point. When the first bubble of the vapor formed during the decrease of pressure, as the pressure is further reduced, the amount of vapor increases and the amount of liquid decreases. When the liquid phase is almost gone, the dew point is formed and it lies on the PY1 curve, which is the red curve. Once the dew have evaporated, the saturated vapor remain. Further pressure reduction will lead to superheated vapor. The figure shows the TXY diagram for ethane and propane, which is the same system as before, at constant pressure of 1 atm. The bubble point lies on the TX curve, which is the blue curve, where the first bubble of vapor appears when the temperature of the liquid is increased. As the temperature further increases, the amount of vapor increases and the amount of liquid decreases. When the last drop of liquid disappears, the dew point lies on the Ty curve, which is the red curve. Because of the distillation processes are carried out more nearly at constant pressure than constant temperature, the TXY diagram of data at constant P are great practical interest.
So these are the safety issues when we'll be handling ethane and propane gases, as they are highly flammable gases. It also contains gas under pressure which may explode when they are heated. So therefore, it is critical to guarantee correct handling and control of it. We should keep it away from heat, sparks, open flames, or hot places, and do not smoke when handling them. Besides, we should not extinguish unless leak can be stopped safely when they are leaking gas fire. Besides, we should eliminate all ignition resources if safe to do so. For the storage, we should protect it from sunlight and store it in a well-ventilated place. So this is the conclusion for our group project, that using equimolar mixture that fed into the flash separator at T equals to 200 K, and we can get the most of liquid, liquid phase mole fraction, most of vapor, and vapor phase mole fraction. So when designing a flash separator to separate the ethane and propane, it is important to consider the system's behavior. Calculating the amounts of liquid and vapor along with their respective composition helps to refine the system and operating conditions. By utilizing the provided data, the unit can be adjusted to achieve optimal separation results. These are the references that we use for our group project, and it is arranged using numbering system. That's all for our group, and thank you for watching.